All right, guys, Mr. Mathwiz here, just doing a quick review on Lesson 3. This might be a two-part clip if I don't get through this all quickly. All right, so Lesson 3, we were still working with adding positive or negative integers. In the last lesson, we did it with a number line. On this lesson, we used physical models or tokens. I didn't have actual tokens for you to play with, but keep in mind there is a link in your Google Classroom where you can use that website, or you can just draw them. Sometimes that's easy enough. All right. So when we did it with the tokens, what we discovered was that basically you would treat it like you have positive tokens and negative tokens. So if I had the situation, I think I'll use the same problem as the last lesson. So in the last lesson, I had -3 plus 5. So to do that with our physical tokens, I would draw out 3 negative tokens. So I have 1, 2, 3. You could just leave them like that, or if you want to put a little circle around them to show that they're physical tokens, that's fine too, right? So I've got 3 negative tokens, and then I have 5 positive tokens. 1, 2, 3, 4, and 5. So I've got my 3 and my 5. 3 negatives and 5 positives. So what we learned at the beginning of Lesson 3 is what we called zero pairs. Zero pairs is a vocabulary word that you will want to make sure you understand. Zero pairs. So zero pairs are two numbers that add up to 0. And we said that the most common ones that we see and the ones that we use with this model are when we think about -1 and +1. Because -1 and +1, if you add them together, it's always going to come out to 0, right? But we said that zero pairs can be any numbers as long as it's a positive and negative of the same ones. So it could be -7 and +7, -3 and +3. Oh, that's not 3. But you get what I'm saying. As long as the negative and the positive are the same number but with different signs, they have the same absolute value. Remember that term. That was another vocabulary term from this unit, absolute value, right? So if they have the same absolute value but one is positive and one is negative, then we call that a zero pair. So when we're talking about these models, these tokens, we're looking for the zero pairs, and we're going to remove them. So in this case, we have 3 negatives, and we have 5 positives, which means that we have 3 zero pairs. So we have these 3 over here with the negatives, and then we're going to take out 3 positives, right? So all that is our zero pairs. And so they basically add up to 0. So if you think of it, it's 1 and -1, and it happens 3 times. So it's basically +3 and -3. They cancel each other out. So all that's left in this problem are these 2 tokens here, which are both positive, which means that the answer to this problem is +2. So when we're doing it with the manipulatives, with the tokens, we just lay them out or we draw them out, and we remove the zero pairs, and whatever is left is our answer. So pretty straightforward. A lot of you said that you found this really easy to do. So that is great. That's the big idea behind the manipulatives. So I would definitely practice that. There's some good problems in the lesson if you didn't get them all done during class. There's also some good work in Mathia with this stuff. So that would be what you would want to do with the manipulatives. And then what we talked about at the end of Lesson 3, because we did Lesson 3 in 2 parts in class, but what we talked about at the end of Lesson 3 was basically the rules for adding integers. So what we discovered here, if you look at this problem, our answer was +2. One of the rules that we discovered, we discovered lots of rules. One of the rules we discovered when we did a bunch of adding with number lines and with manipulatives is that if you add 2 positive numbers, then the answer is positive. And if you add 2 negative numbers, then the answer is negative. So if we did this with manipulatives, it's pretty straightforward to see. So if I added 2 positives to 3 positives, I have no zero pairs to remove, right? There's no pairs, there's no zero pairs, there's no positives and negatives tied together because the only tokens I have are positive. So if I had all these together, that means that 2 positives and 3 positives equal 5, which 2 plus 3 equals 5 is something you should definitely know, but now you have a visual model to see it. If we did it with negatives, if I had 2 negatives and I added 3 negatives, well, I have no 0 pairs to remove. So I have a -2 and I have a -3. So I'm adding -2 and -3. My answer becomes -5 because I have 5 negatives. I have no positives in that situation. So that was one of the rules we talked about. Whenever you add two numbers, if they have the same sign, your answer is always going to be that same sign. And the quick way to do it is just to add those two numbers together. So the shortcut that we learned today in the second part of lesson 3 is that if two numbers are the same sign, to figure out the answer is, all you have to do is add those numbers together and throw that sign on there. So even if I had a big number, like -123, and I'm adding -17, right? I could do this on a number line, and I could do this with tokens, but it might be a bit cumbersome because those are pretty big numbers. And doing those with tokens or number lines would be difficult. So the shortcut to that, first off, I know that they're both negatives. I can see that -123 and -17 are both negatives. So whatever my answer is, I know it's going to be a negative number, because if you add two negatives together, your answer is always going to be negatives. So if I think of it with the tokens, even though I'm not drawing them, if I think about it, I've got one side which is 123 negative tokens, and then I have another side which is 17 negative tokens. So our answer is just 123 plus 17, which if I do that, 7 and 3 is 10, so I got a 0 there, carry the 1 over. 1 plus 2 plus 1 gives me 4. So 140 is what I get when I add those two together. But my answer to this problem is not 140 because both those tokens are negative. I've got -123 and -17, which means my answer is -140. I hope you guys followed that. So whenever you're adding two numbers together, if they're both the same sign, if they're both positive, you add them together and the answer is positive. If they're both negative, you add them together and the answer is negative. So the second rule has to do with when we're adding things that are positive and negative, when one number is positive and one number is negative. So that rule looks a little bit more complicated, but still pretty straightforward. Let's go back up to the top, actually. So over here I had -3 and I had +5. Notice the two that I had left over are positive. And that's because the smaller number, these 3 here, let me draw it again. These 3 here, right? There's less of those than there are the 5, which means that when we did our 0 pairs, all of those canceled out. Here's the thing, that's always going to happen. That's always going to happen. So if I have -7 and I'm adding +2, if I did it with my tokens, that's going to mean that I have 7 negatives, right? And I have 2 positives. So when I find my 0 pairs, how many 0 pairs can I get? Well, I can only get, the most 0 pairs I can get is 2, because that's my smallest number, right? So both of these are going to go away with both of these, and what's left is those 5 there, and my answer is -5. So whenever you add, basically here's the rule. Whenever you add a positive and a negative integer, so they're not the same sign, they're different signs. One's positive and one's negative. If you add a positive and a negative integer, your answer will be the same sign as the number with the larger absolute value. Remember, absolute value means whatever the number is without the sign. So in this case, when I have my -7 and my 2, the -7 has a larger absolute value, which is just 7. And the 2's absolute value is 2, right? So, I've lost my H there. All right, so I have -7 and I have +2. So the -7 has a larger absolute value, which is 7. So I know that my answer is going to be negative. So here's the shortcut when we're solving these. If you have a negative and a positive, and let's say you don't want to use a number line and you don't want to use tokens, what you're actually doing is finding the difference between them. It's basically a subtraction problem. So if I have -47, and I am adding it to +23, I might not want to do that on a number line, and I might not want to do that with tokens. It'll take me a while to draw all those, right? But if you think about it this way, if you think about it with the tokens, you got a bunch of negatives and you've got less positives. So all those positives are going to cancel out. So all that's going to be left is negative. My larger number, my larger absolute value is that negative 47, right? So whatever my answer is, it's going to be a negative answer. I know that before I've even done the problem. So now to figure out what the number is, I'm going to subtract 47 minus 23, which you guys should be able to do. I got 7 minus 3 is 4. 4 minus 2 is 2. So my answer is not 24, but it's negative 24 because my larger of the two numbers was negative. If the larger of the two numbers is positive, and this is still going to apply, right? So if I have positive 47 and I'm adding negative 23, then I'm just doing, my answer is going to be positive, right? And I'm just doing the 47 minus 23 again. I'm still doing this same thing. It gives me 24, but this time I'm going to have positive 24 because the larger of the two numbers was positive. All right, I hope you all follow that. These are important rules. We'll be touching on them more, and you will definitely need to know these when we test on this unit, because keep in mind you will not be using a calculator on this. So if you didn't finish lesson 3, there were a lot of good problems in there. You should have gotten through almost all of it during class, but if you did not, go back and do those. The answer keys are posted, and you guys have a great rest of your day. And then next week we'll start lesson 4.